sort of burning up in the atmosphere, 8 or 9 different effects. And on the team, we had people saying we'll see 0 of those changes or all of those. So we really don't know, which means it's a great learning opportunity.
And somebody's going to make some money from the betting pool here, I guess.
Here's a question from one of our viewers via Twitter. Is it possible to retrieve some of the dust and ice being shed by this comet? I think, let me answer half of it for you and let you finish up. Not this comet, but there's something really exciting coming up next month from a comet.
I'll let you take that one, Dave.
Well, I think you're probably referring to the landing on Comet 67P by the Philae lander from the Rosetta mission, which is now in orbit around another comet. And it is an interesting time in the solar system as far as interacting with comets, because we've got that going on as well. But no, I mean, there's nothing on these orbiters that we have or rovers that we have on Mars now that's capable of capturing some comet dust and sort of bringing it back or analyzing it. I mean, I suppose we could get really lucky with the Curiosity rover, and a piece of comet dust could land there and they could pick it up. But I don't think that's in the plan. It's more an opportunity to do some remote observations.
That's right.
I got a question for you, Nick. So there's obviously an opportunity to see something happen to the atmosphere that you can study. Does this create any headaches for your mission as far as you want to sort of see what the Mars atmosphere is like when it's normal and then study it when it's perturbed? And here you are showing up and this massive thing happens to it. And so how do you know what's normal? Have you guys worried about that at all?
Yeah, absolutely we have. Could you bring up one of the other graphics that I sent ahead that shows what our instrument is capable of creating in the study of Mars? This would be an image of Mars and its upper atmosphere. So it's here it shows our ability to see how high the different gases are extended. And so if you're looking at that image, I think it's up, there's a blue glow of hydrogen which extends far up into space, oxygen not quite so far. So we've been capturing data like this, we hope, in the last couple of days. And so this is, like those diet commercials. This is Mars before, and we're going to have Mars after. When we come out and get the all clear, we hope to go right back to observing in a few hours. And we actually think that the influence of the comet is probably going to be short-lived, with a few exceptions. But it was really important, exactly as you say, to get that before picture so we know that we're not just seeing the Mars entirely as affected by the comet.
So that gave you extra incentive as soon as you got there to start getting some good observations. And it looks like, at least from this gorgeous image you're showing us, it looks like you've been able to get some good baseline to then compare what happens.
Absolutely. Well, the real credit goes to the hardworking team at Lockheed Martin that had to cram in all of our commissioning exercises in a fraction of the time.
Yeah, and let me ask you both this. Am I right in assuming that a lot of the missions around Mars and the rovers on Mars are sort of being temporarily repurposed to take advantage of this serendipitous event?
That's right. I've heard it called once in a lifetime, but it might actually be more accurately once in a million years. This is a really rare event, and it's why people are really pulling out the stops to make these observations happen.
But I mean, some sensors that were looking at the ground, like with the rovers, are now going to be pointed skyward, and some skyward pointing instruments are going to be pointed toward the ground. Is that right, Dave?
Yeah, I mean, I doubt anybody's complaining like, oh, we didn't get to look at that rock we were going to look at this weekend, because as Nick said, it's a very rare opportunity. But absolutely, the plan is being interrupted, and certainly for the rovers, they're going to stop what they're doing and try to actually see if they can see the sky.
Dave, let me pause you for a second. We seem to be having a little problem with your audio. I tell you what, this is a convenient time. We're gonna take a quick 30-second break, and we'll see if we can fix your audio. We don't have to go all the way out to space to do that. And we'll be back with more from Slooh.com. So stay with us. We will be back in 30 seconds. And this is Slooh.com's live coverage of Mars versus Siding Spring, the comet that had its close encounter with Mars just a little while ago. Before we get back to Nick and Dave, let me just tell everybody that the reason Slooh does this is because Slooh is the community observatory. We are always interested in things that happen in the sky. Our members command our Slooh telescopes, our 3 telescopes on 2 continents at 2 observatories. They set the missions, and if you're at all interested in the sky, if you would like to have access to some really fine instruments for stargazing, for looking at galaxies, for checking out comets and asteroids, we'd love to have you as a Slooh member. Check it out on our website. It's slooh.com, SLOOH.com, and there you see we have an introductory membership offer that's available now. So you can spend just a teeny bit of money and see if Slooh is right for you, which we think it is. And if you join today, we'll be glad to send you one of our Slooh full lunar eclipse T-shirts from that lunar eclipse that we just had a few weeks ago. All right, so we're back with Nick Snyder and Dave Grinspoon, and we're talking about the comet. And Nick, you have this phenomenal satellite that has just come to Mars. Really briefly, because we're going to have to let you go, tell us exactly what in your wildest dreams, what will you find out when your data comes back that you don't know now?
So I have to remind everybody that the comet has been fading in intensity recently, and so there's a possibility that this is not the comet that we saw coming at Mars even a month or 2 ago. So the effects may be small. We're trying not to get our hopes up.
It's the same comet. It's just it may have been overestimated.
Sorry, figure of speech. But the kinds of things that much gas and dust can do might be to really puff up the upper atmosphere, even cause aurora on the night side. We've got a whole suite of instruments that measure charged particles and fields, and comets are really known for being able to mess those up as well. So we're scientists. We're not we don't have a vested interest in this, but boy, would we ever love to see just a planet that's been sort of whacked with a hammer, and then we just want to see how it responds.
Yeah, and there on the screen you see all the NASA assets, many of which are really not normally used to look at planets or comets, which have been repurposed for this mission. Nick Snyder, I'm going to say goodbye to you now. Thank you so much for joining us and helping us out in our broadcast this afternoon. And good luck with the MAVEN mission. We're looking forward to hearing a lot of really cool science from you.
Yeah, thanks a lot, Nick. It's great to see you. And
we may have data on the ground, and we're going to go have a look at it.
Well, enjoy that, and give our regards to everybody on the team.
Okay, thanks much. So long.
All right. So, Dave, here we are, and we are looking at this comet, which is now gone by Mars, but we're waiting for what happens about an hour, maybe an hour and 15 minutes from now, when the fluence, do I have that the correct term? The fluence goes by. Tell everybody what that is.
That's a technical term for all the crap that's coming off the comet. It's gonna hit the planet. But yeah, I mean, there's a delay because there's the technical moment when the nucleus of the comet, the solid object, is at its closest to Mars, which is the moment we just passed a few minutes ago. And then you can picture this sort of fanning out diffuse cloud of debris, gas, and dust that's coming out and sort of expanding into the tail and the coma, the more diffuse cloud. And that, it takes a little bit longer, and it's going to be about an hour from the closest approach of the nucleus till the maximum effect of that stuff sort of sweeping into the upper atmosphere of Mars, the gas and perhaps some dust as well.
Timo writes, what about the moons Phobos and Deimos? Are they in danger at all?
Well, I don't think danger is the right word. In other words, those moons have been there for billions of years. They've been through a lot. It's not like they're going to, crack up or go flying out of their orbits. But, yeah, they'll be affected. Certainly, there'll probably be some light dusting, which I say light, but, again, we're talking about you know, tens of kilometers per second. So a light dusting is, you know, there'll be some impacts for sure on those moons, and they'll get sort of, there'll be a puff of gas that comes up against them. I would doubt there would be a huge observable effect on those moons. Certainly if we had an asset right there, if there was a spacecraft on or around one of those moons, it would be fun to watch, because I would imagine if you were close up on the surface, you might see some of that dust, you know, making little micro craters and puffing up some stuff from the surface. I doubt that will be something that will be observable from a distance. I would love to be proven wrong about that.
But from Earth, obviously, any cometary dust would normally have to go through our atmosphere. That is much less of a concern on Mars, and certainly no concern at all on the two moons. So anything coming in will come in 100% at its speed.
Yeah, anything hitting those moons will hit them at full orbital speed, which is, I think I wrote it down here for this particular comet. It's something like 56 kilometers per second, or 35 miles per second. That's that's even for orbital speeds, that's really fast. That's higher speed than most comet impacts. Aren't even that velocity. This thing's coming right in from the Oort cloud at a very steep angle. So this, even for a comet passage, is really high velocity. So yeah, anything that hits, kinetic energy of an impact, the formula, that we know, it goes as the square of the velocity. So if you make something twice as fast, it's 4 times as much energy. So velocity really matters. So yeah, the energy of any even dust stuff hitting something from this thing will really be felt by that object.
Let's put it in our perspective a little bit. Have comets hit the Earth?
Comets have definitely hit the Earth, and probably will again, unless intelligent life evolves here and decides to do something about it, which seems like it might be happening. But, the famous example, of course, is 65 million years ago, the big mass extinction that took out the dinosaurs and most other species at that time. Yeah, it made the Chicxulub crater, and we don't actually know for sure if that was an asteroid or a comet, although there's some suggestion that it probably was a comet. But certainly comets have hit the Earth in the past, and there's small ones that hit more frequently. That one that hit 65 million years ago was about 10 kilometers across. That's a big object, and something like that happens, and it really has massive global effects. And certainly, if you go back in time to the origin of the Earth and the time of the origin of life, there were a lot more comets hitting the Earth. They have some ice, but they're primarily rocky, and they orbit mostly in this belt, the asteroid belt between Mars and Jupiter. Some of them orbit closer in. They're Earth-crossing asteroids, but they're from mostly the inner, or not the very outer part of the solar system, and they're mostly rocky. Comets are mostly ice and dust and organic material, interestingly for us and life, and they inhabit generally the far outer reaches of the solar system in this Oort cloud, way beyond the zone of the planets. And they're mostly just out there in cold storage, and then occasionally one like this one we're watching gets perturbed in its orbit and comes flying into the inner solar system and does all these interesting things with the gas and the dust and the tail and so forth.
I know this is a tantalizing thing to mention late in the show, but can you talk a little bit about something that I've always been fascinated by, and that is the concept of Panspermia, that maybe we're here because comets brought us here, or at least brought the building blocks of life here?
Well, one thing we know, I mean, panspermia literally means seeds across the space, from the root of the word. One thing we know for sure is that the planets exchange material, because we've got some chunks of rocks here, of Mars here on Earth. And that happens when objects hit the planets, including comets. So comets certainly we know can cause panspermia in the sense of scattering rocks at high velocity from one planet landing on another, which could carry life. We know bits of Earth get knocked off in impacts and will occasionally land on Mars or Venus or other planets carrying life. So that part is not controversial, that sort of natural exchange of material between the planets that can be caused by comets. Could comet dust bring life to a planet? That's been proposed, and it's not completely out of the question, but the problem is, how did that life get into the comet? And some people think, well, you know, comets have water in the form of ice, and they have organic matter. Maybe you could have an origin of life in the wet interior of a comet. It's possible, but, you know, trying to be a good scientist here, I have to be skeptical and say we haven't seen any evidence that life can evolve other than on a planet. And so that's one of those ideas that's out there, but not maybe mainstream.
Is the Martian atmosphere thick enough to get a meteor shower? This question is from Eileen via Twitter, Dave.
Absolutely. You think of where most meteors burn up in the upper atmosphere of Earth. They don't make it to the ground. And the surface of Mars, the pressure there is something like what you would find up at the level up, you know, many miles up in Earth's atmosphere at the level where most of those meteors burn up. And so what you might get on Mars would be very interesting, a meteor shower somewhat closer to the ground. It could be very spectacular if you were on Mars watching this. But there's definitely enough density there so that you would get the resistance and the friction and the heating that causes a meteor shower. In fact, picture when our landers come in, the 7 minutes of terror, and the fact that you get a fireball from a NASA lander coming in, you know, all that resistance, that shows you that even though the air's thinner, it can still cause a lot of friction and a lot of heat. And it's the same thing happening on a different scale that makes a meteor from a bit of dust coming in from a comet.
Sure, and where we see our meteor showers in the Earth's atmosphere, it's actually happening at an altitude where our Earth's atmosphere is exceptionally thin.
Yeah, it's like Mars up there.
Yeah. Well, listen, we're gonna stop it right here, Dave. But let me tell folks what's going to be going on later today. Obviously, we've had the closest approach to Mars, but we're going to come back at 8:30 Eastern Time. That's 5:30 Pacific, 00:30 Universal Time. That would be Monday morning if you're going by Universal Coordinated Time, but Sunday afternoon or evening here in the United States. And the reason that we're coming back is because we are hopeful. Now, we can't promise, but we are hopeful that by that time, NASA will be able to take a look at some of their instruments on some of their orbiters and through the Deep Space Network get data back, and maybe, and again, we cannot promise, but maybe there will be some imagery to show you, some more close-up imagery from around Mars or from some remote sensing to give you a much better idea of what's gone on this afternoon near the planet Mars, and with this sort of amazing comet that's taken millions of years to come in from the Oort cloud and is about to make its closest approach to the sun. I've written that down, David. Is that's October 25th. That's the perihelion. So there will be more, and for that we will be on again this afternoon, David and I. Again, that is 8:30 Eastern, 5:30 Pacific, 00:30 Monday morning if you're on Universal Coordinated Time. Meanwhile, this broadcast has come to you from Slooh.com. Slooh is the community observatory. Our members use the Slooh telescopes, the 3 telescopes, to look at the sky. It's a way to get around the fact that maybe you have light pollution where you are. Maybe you can't afford the price that it costs to put in a really nice home observatory. Slooh brings that telescope to you via the internet, and we'd like you to look at our site and see if maybe Slooh is for you. I know that we had over 100 people sign up during our last broadcast. It's a really cool way to see the sky. We have brought astronomy for the amateur into the 21st century. There's our introductory offer, 3 months for $29.95. Check it out at our website, slooh.com. And of course, if you do join today, we will send you that Slooh Total Lunar Eclipse T-shirt. All right, Dr. David Grinspoon, astrobiologist, I'm going to give you an opportunity here to give everybody a takeaway before we go away.
Well, I guess that my takeaway is just that the solar system constantly surprises us.
Wow. I got to keep everybody reminded. There'll be more information that comes in. They had already told us it'd be at least 3 days before we get the information from Mars. So, hey, good to see you guys in here.
Hey, Brother Matthew, that was really interesting how they called it dust.
Yeah.
They didn't call it an electrical field. They called it dust.
Right. Yeah, well, I'm sure. Well, listen, they know people are looking at things, and there's doomsdayers and stuff. So I'm sure their tone is toned down.
Yeah.
Ask Chris what charges the electric tail. Judy's asking Chris.
Yeah. According to James McKinney's comet discharge model, as a comet is coming in through the solar system, as it picks up speed, it picks up energy. It also it starts converting energy into hydrides, I believe. Plus, there's also an electrical interaction between the sun and the comet, because basically the sun is a big solar battery, and there's a lot of high energy particles floating around in outer space, and the comet picks up all on that. The planets are connected to it. The comet kind of slams into those connections as it's moving through. A comet Ison
Something.
came in at such an angle, it was slamming against that electrical field as it came in. This one's kind of going up at an angle, but it's still energized. But you'll see where the solar tail from the solar pressure hits the comet one way, but the electrical connection between the comet and the rest of the solar system is at an entirely different direction. So when it goes by Mars, it's gonna, engulf it in electrical.
Right. They're saying the atmospheres. It seems evident that the atmosphere is what collides so far. It doesn't seem likely that there's going to be a deep impact, but there's also the unknowns, the other variables that are involved here. The fact that Nibiru comes up at a better skip and better proximity than Mars does at all. Uh, the fact that there was a possibility of a Mars collision came secondary in this table. The fact that Wormwood sits right up under it and where it does, we know in itself Wormwood is a completely separate event than this comet. Now this comet is like coordinates in the code. It gives us the width and gives us a matrix. It's also given us a season of time, and God has put these verses in there. Not all the verses point to one day, October 19th, things are happening, but God is showing us, I believe, the season that we're in. We're very close to Wormwood. Each one of these comets has gotten closer and closer. The skips have gotten smaller. If you recall in the Ison table, Wormwood is vertical with several rows in between. But in this table, it's in one line. And not only that, there's multiple words in one line in that area that are all related to Revelation. So
I've seen a lot too. How instead of getting vertical ELSs, I'm getting a lot of horizontal ones that actually run right along with the scripture.
I've been seeing it
My
more
last
too.
table, the Psalm 91 table that I just did, you have salvation with a Tav running forwards, but directly right behind it going backwards, you have Ebola with 5775 running right down through the middle of it. I've never seen that before.
Yeah. Listen, there's going to be more to come. I don't believe this is going to be the last comet. I think there's going to be others that tell us something, and God uses these things to communicate as well as instruments of destruction.
Can I interfere here for a second? I don't mean to do this, but I'm private chatting with Johnny Mayhery. He's actually asking me questions that should not be asked in here. He asked about my privates. He's saying he's horny. Can somebody please deal with this guy? That's not cool.
Okay. What's the name?
John Merhy. I don't mind meeting new people, but okay, he's just left. No, I don't mind meeting new people, but that's a little too much.
Tim, you're not a moderator in here?
No, I am not.
Okay, guys, help me out here. Johnny on the spot. It's not cool. You're absolutely right.
He just left, but
You're absolutely right. See, we'll get that kind of thing.
I'm gonna go ahead and pop off of here. Yeah. I figured I had to warn everybody that this stuff's already happening, so I'm gonna get off of here and leave you guys talk. Thank you.
Yeah, to our audience, this is a public place, and it would be wise if you're nice to the rest of the patrons, be godly, be God's children. I know that we have some people that come in here who aren't believers, but we have mods, and we're not afraid to ban people if they're misbehaving, so just to let you know that.
Sorry about that, Tamara. Those kind of things are going to happen. People just don't know how to act. They got issues. They got spirits. Just got to pray for them. Yes, I got it. I'll call you in just a minute here. I'm monitoring something right here.
So that was a pretty interesting. We've seen Australia, we've seen Italy. Where's this Slooh situated? Does anybody know where the Slooh Observatory is situated?
I wasn't sure where it was myself.
Somewhere in the United States. Okay. Okay. Thank you, Em. So, I'm just going to sign out because I don't know what we're doing next. There's going to be a broadcast later, I guess, from the Slooh Observatory, so maybe later, if they do a live broadcast, we can meet back later. I don't know if they have an advertisement for it yet. Yeah, make sure you mark this page, tinychat.com/YHVH HIS salvation. YHV, his salvation, 2 S's. Okay, so thank you everybody for coming, and God bless you all, and to all of you who are not saved, if you're visiting, you might want to think about a relationship with Jesus Christ. It's a wonderful relationship. It gets sweeter every day.